you've ever been to the beach and you've sat there at the beach, one of the main things that you actually hear when you're sitting there at the beach is waves crashing on the shore. And those waves are actually formed far, far, far out at sea. And what a wave actually is a flow of energy or motion, right? So a wave is just simply a flow of energy or motion and is not actually a flow of water. So when those waves are crashing on the shore, at the beach, wherever you are, those water molecules that are actually moving are not the water molecules that got started moving out in the open ocean. So the water molecules that got started moving in the open ocean just simply moved and then passed the energy on to the next water molecule and the next water molecule and the next water molecule and passed the energy, but the water molecule itself actually just travels in a small circular motion, which we will look at in just a minute. In order for a wave to start forming, you need to have what's called generating force. So a generating force is going to be the force that actually disturbs the surface of the water. So like when you toss or drop a pebble into water, and it creates the ripples. Those ripples would be, like waves, and that dropping of the pebble would be the generating force. The most common generating force for waves in the ocean is wind. So the blowing of the wind pushing on the surface of the water will create most of the waves. You can also get geological events like geological events like earthquakes, or falling objects like icebergs breaking off, or like ships going through the water also create waves. So you get a generating force that disturbs the surface of the water, and then you also need a restoring force, which is the force that's going to restore the water to the undisturbed level. So for most of the waves that are found in the ocean, that's going to be gravity. So wind's going to pick the water up and disturb the level, and then gravity is going to pull it back down. So the generating force is the wind, restoring force is gravity. Just some terms that you need to know for waves. So you have the wavelength, okay, is the length from crest to crest of a wave. And so this is one wavelength, okay? And a crest is the highest point on the wave. So one wavelength is the distance between those two crests. The trough is the lowest point on the wave, so that would be here. And then the wave height is the distance between the crest and the trough. The period of a wave is how long it takes for one wavelength to pass. So if you're sitting here at a fixed point, it's how long it takes to go from this crest of the wave to the next crest of the wave. So that would be the period of a wave. When a wave passes through, like we were talking about earlier, the water molecules don't actually move towards the shore. What actually happens is water molecules actually move in a small circular motion. So when the wave wind blows on the surface of the water, it picks that water molecule up, right, and then gravity drops it back down. And so what actually happens is the water molecules move in a small circular motion. But when it moves in a small circular motion, it transfers the energy that was given to it by the wind, and it transfers it to the next water molecule, and that water molecule will move in a circle, and so on and so forth. And so the energy gets passed along, but the water molecule itself does not. So wave starts to get formed as soon as the wind begins to blow. And the faster and the longer that wind blows, the larger the waves are going to be. So if you have like a super strong wind that's blowing for a long time, you can get huge, huge, huge waves that form. But if you have a very gentle breeze with the wind that's not blowing for very long, then you'll only really get ripples. The size of the wave is also going to depend on this thing called fetch, which is the distance over which the wind is blowing on the water. So the larger fetch, the longer time, and the stronger the wind, you'll get bigger waves. Smaller fetch, short amount of time, weak wind, you will get small waves. You get different kinds of waves. So you get progressive waves that are generated by wind and restored by gravity, and they go in a certain direction. And you can have different kinds of progressive waves. So you have forced waves that are formed by storms, okay? And the storms will determine the size and the speed of the wave. Um, and they're called forced waves until they, get away from the storm, and then they're called free waves. Okay, and so the free waves will travel for long distances, and will eventually settle into these things called swells. Swells are very long period uniform free waves that carry lots and lots of energy, and swells can go for thousands and thousands of miles. And if you've ever been out on the open ocean on a boat, you probably have experienced swells, which is the waves, the movement of the waves.